the cross product. In momentum. In some two-dimensional and many of three-dimensional problem problems to follow. It is convenient to use a vector approach for moment calculation. To use a vector approach for moment calculation. The moment of F about point A, for example, of this picture. Consider this picture, the moment of F about point A, this point, with the direction, with the distance which represented by R, may be represented by cross product expression M equals to R cross product F, where R is a position vector which runs from the moment reference point A to the point of on any point of force F line application. R also can be here, R. For calculating in two-dimensional cross products R multiplied to F, we should in three-dimensional Rx, Ry, Rz, Fx, Fy, Fz. In the case of Rx, in the case of 0 F, we have I product 0, and for J also 0, and for K we have this relation Rx Fy minus ry fx k. The magnitude of this expression, the magnitude m r f, and the magnitude of m equals to fr sinus alpha fd from this picture. This is alpha. Which agrees with the moment magnitude as given by this equation here. Note that the moment rd equals to r sinus alpha does not depend on the particular point on the line of action of f to which the vector r is directed. We establish the direction and sense of m by applying the right hand rule to the sequence r cross product f. If the fingers of the right hand side are curled in the direction of rotation from the positive sense of r to the positive sense of f, then the thumb point in the positive sense of m. We must maintain the sequence r cross product f because the sequence f multiply r would product a vector with a sense opposite to that of the correct moment. As was the case with the scalar approach, the moment m may be thought of as the moment about point A or as the moment about the line OO which passes through point A and is perpendicular to the plane containing the vectors r and f as shown here. F and r perpendicular to this plane. When we evaluate the moment of a force about a given point, the choice between using the vector cross product or the scalar expression depends on how the geometry of the problem is specified. If we know or can easily determine the perpendicular distance between the line of action of the force and the moment center, then the scalar approach is generally simpler. If, however, f vector and r vector are not perpendicular and are easily expressible in vector notation, then the cross product as shown here expression is often preferable. In section B of this chapter, we will see how the vector formulation of the moment of a force is especially useful for determining the moment of a force about a point in a 3-dimension with this relation. The next section is Varignon theorem.